Okay, so I picked these two exponential application questions because one of them, the formula is given to you, the other, the formula is given, but it asks the question in kind of a weird way, and you got to be careful about units. So we've got Sean. He invests $10,000 at an annual rate of 5%, compounded continuously. You need to know that if the words compounded continuously are used, it's the A equals PERT formula. This tells you A is the amount, P is the principal, R is the rate of interest, T is time in years. Determine to the nearest dollar the amount of money he will have after 2 years. Nearest dollar. I'm going to make sure we do that. All right, so we're just going to plug into the formula. So first of all, the amount he's going to have after 2 years, A of 2, is his initial investment, or the principal amount. E, a rate of 5%, which is 0.05, times T, which is 2. This is the only formula, pretty much, that we don't do 1 plus the rate or 1 minus the rate. So it works differently than the other ones. So if we go to our calculator and we figured this out, A of 2 equals, and we're doing nearest dollar, don't forget. So nearest dollar, let's see, 10,000. E to the 0.05 times 2. 11,052. Yeah? $11,052. So after 2 years, he makes $1,052. I'll take it for doing nothing. Okay. So determine how many years to the nearest year it will take for his initial investment to double. All right. So double of 10,000 is 20,000. I know that I insulted your intelligence by saying that. I apologize. E to the 0.05t. So we want to solve this. Our first step, like 99% of the time, is divide, right? So divide by 10,000. And that gives us a 2 equals E to the 0.05t. So now we can log. So I want to get the exponent down, so I change it to a log. Log base E is ln, so ln of 2 is equal to 0.05t. To solve for t, we got to divide by 0.05. I don't know why I just put an extra 0 there. So t equals. Remember, we're doing nearest year, too. So ln of 2 divided by 0.05. ln of 2, 0.05. 13.8, so 14 years. Fabulous. Okay, what's the next one? In the equation, 0.5, 1.21 to the x, y represents the number of snowboarders in millions, and x represents the number of years since 1988. Explain what the numbers 0.5 and 1.21 represent. Well, we've done enough of these, I think, at this point that we know the number out front is the initial, right? The initial population, the initial amount, the initial whatever. So 0.5, well, you can't have 0.5 snowboarders, but its initial population of snowboarders is in millions. So it's an initial 500,000 snowboarders. So 0.5 represents an initial 500,000 snowboarders in 1988, right? That's what year they're referencing here. Okay, 1.21. Well, we know that number in the parentheses is 1 plus the rate, right? So we know that it's growth at a rate of 21%. So 1.21 represents growth at a rate of 21%. Okay, beautiful. Find the year, so the date, like 2025, in which the number of snowboarders will be 10 million for the first time. So because this is in millions, I'm just putting a 10 on the left. 0.5, 1.21 to the x. So, step 1, divide by 0.5. Get the weird thing alone, right? So that would be 20 on the left. 1.21 to the x. Undo the weird thing. So change to log. Log base of 1.21 of 20 is equal to the exponent. So, and we're going to find the year. So let's get the number first. We're going to add, whatever we get, we're going to add 1988 to it. So, log 1.21, 2 plus 1988. Why does that look wrong to me? Did I type that right? 20. Hello, Newman. No wonder I felt crazy. You gotta tell me when I do those things. 20. There we go. Plus 1988. How about 2003? So if we're 0.7 of the way through 2003, we're still in 2003. So 2003. Wonderful.